There is a good chance that penicillin has saved your life. Without it, a prick from a thorn or a sore throat can easily turn fatal. Alexander Fleming generally gets the credit for penicillin when in 1928 he famously observed how a mold growing on his petri dishes suppressed the growth of a nearby bacteria. But despite of his best efforts, he failed to extract any usable penicillin. Fleming gave up the story of penicillin and took a 10-year hiatus, until in 1939 it took Australian pharmacologist Howard Florey and his team of chemists to figure out a way of purifying penicillin in usable quantities. However, as World War II was raging at the time, scientific equipment was in short supply. The team therefore cobbled together a totally functional penicillin production from bathtubs, milk churns and bookshelves. Not surprisingly, the media were extremely excited about this new wonder drug, but Florey and his colleagues were rather shy of publicity. Instead, Fleming took the limelight. Full-scale production of penicillin took off in 1944 when the chemical engineer Margaret Hutchinson Rosery took Florey's Halt Robinson-esque design and converted it into a full-scale production.
While you may not experience allergic symptoms the first time you take a drug, your body could be producing antibodies to it. As a result, the next time you take the drug, your immune system may see it as an invader, and you'll develop symptoms as your body releases chemicals to defend against it. These symptoms may include skin rash or hives, itching, wheezing or other breathing problems, swelling, vomiting, feeling dizzy or lightheaded, anaphylaxis, which is a potentially life-threatening reaction that can impair breathing and send the body into shock. Reactions may simultaneously affect 2 or more organ systems. For example, when there's both a rash and difficulty breathing. Penicillin causes most allergic drug symptoms. Just because you show allergic symptoms after taking penicillin doesn't mean that you will react to related drugs. Also, just because you had a reaction to penicillin or any other drug at one time doesn't mean that you will also have the same reaction in future. Antibiotics that contain sulfa drugs, such as Septa and Bactrim, occasionally cause allergic reactions. Non-antibiotic drugs containing sulfa are very low risk.
How did they make penicillin? For many years, scientists knew that certain molds killed some bacteria. However, researchers needed to understand how to harness this antibacterial microbe and to manufacture enough of the substance before they could make a useful medicine. Penicillium mold naturally produces the antibiotic penicillin. Scientists learned to grow penicillium mold in deep fermentation tanks by adding a kind of sugar and other ingredients. This process increased the growth of penicillium. Then scientists separated the penicillin product from the mold. Finally, penicillin is purified for use as an antibiotic medicine.
Trials of the drugs on humans were so successful that great quantities of penicillin were used to treat infections suffered by wounded and ill soldiers during World War II. England was not able to manufacture penicillin in quantities because of its involvement in the war. Florey travelled to the United States and convinced the government to sponsor research on the mass production of penicillin. An efficient method of mass producing penicillin was developed using fermentation and cornstarch medium. This basic technique is still used to produce many antibiotics. Penicillin prevented thousands of wartime deaths from gas gangrene and other infections. Now the race began to discover its molecular structure so that it could be produced scientifically. Penicillin helped reduce the number of deaths and amputations of troops during the World War II. According to records, there was only 400 million units of penicillin available during the first 5 months of 1943. By the time World War II ended, US companies were making 650 billion
Antibiotic resistance occurs when bacteria change in some way that reduces or eliminates the effectiveness of drugs, chemicals, or other agents designed to cure or prevent infections. The bacteria survive and continue to multiply, causing more harm.